One side burns, the other freezes. There is no rotation, no balance, only a thin line where survival is possible, and everywhere else is death. Space looks empty, silent, still, endless. But signals repeat, stars collapse, planets burn. Some things out there should not exist. This is Space Horrors, the universe that should not exist. A normal world has a rhythm. Morning moves, night passes. Heat is carried across the surface by rotation, air, water, and time. On Earth, sunrise and sunset protect the surface from extremes. They spread damage over time. But some worlds lose that rhythm. On a locked world, there is no mercy from motion. The star stays fixed in the sky. The night never ends. They orbit so close to their star that gravity slowly locks them in place. One face is forced toward the light. The other is forced into darkness. Not for a season, not for a year, forever. This is called tidal locking. It does not mean the planet stops moving through space. It means its rotation becomes trapped by its orbit. The same side keeps facing the star. The same side keeps looking away. And between those two regions, the planet becomes divided into climates that should not belong to the same world. One planet, two disasters. On the day side, the star does not rise. It is already there, fixed, unmoving, directly overhead for millions of years. The surface absorbs energy without the relief of night. Rock can bake, ice can vanish, water can be driven upward into the atmosphere. Air can expand until it becomes part of the planet's escape problem. This is not ordinary heat. It is constant forcing, a climate system pushed from one direction without rest. If the planet is too close to its star, the ground may become a desert of overheated rock. If it is closer still, parts of the surface may behave like a furnace. Some extreme exoplanets may have molten regions. Some may carry vapor from hot minerals. Some may keep only a thin atmosphere under pressure from radiation. But even when the surface is not molten, the day side can still be hostile. Clouds may form where heat drives material upward. Winds may tear across the planet, trying to move energy away. Chemistry may change from one hemisphere to the other. The danger is not just that this side is hot. The danger is that it never cools. A world cannot breathe normally when half of it is held under endless daylight. And whatever the day side cannot hold, it's pushed toward the dark. The night side is not simply cold. It is abandoned by the star. No sunrise arrives. No warm season crosses the horizon. No direct light returns to repair the energy loss. Heat radiates away into space. The ground cools. The air above it cools with it. And on some worlds, the atmosphere itself may begin to fail. Gases can condense. They can fall out of the sky as frost. They can collect on the dark hemisphere like a frozen ocean of air. This is atmospheric collapse, not an explosion, not a storm, a quiet failure of balance. The planet still has gravity. The planet still has a surface, but the gas that should wrap around it can become trapped where the star never reaches. Carbon dioxide can freeze under the right conditions. Other volatiles can migrate toward the coldest places. The night side becomes a sink for the planet's own climate. If too much atmosphere collapses, winds weaken. Heat transport breaks down. The day side grows more isolated. The night side grows more dead. A locked world can lose its balance without losing its air to space. It can lose it to itself. And between the burning side and the frozen side, there is only one place left to look. A locked planet is not just surface against surface. It is atmosphere against physics. If the air is thick enough, it can carry heat away from the day side. It can push warmth into the dark. It can soften the difference between the two halves. But that rescue comes at a cost. The winds may become violent. Jet streams may circle the planet. Clouds may form in strange places. Chemistry may be dragged from heat into cold before it can settle. On some exoplanets, astronomers are already reading these patterns indirectly. They measure infrared light. They compare the day side to the night side. They watch how heat shifts away from the point directly beneath the star. Those maps are not photographs in the familiar sense. They are temperature written in light. And the message is clear. Atmospheres can move enormous energy, but they do not erase the danger. They redistribute it. Too little air, and the night side may freeze the climate out of existence. Too much heat, and the day side may overpower the circulation. The atmosphere becomes the only bridge between two worlds trapped on one planet. As that bridge fails, the split becomes permanent. Between permanent day and permanent night is a boundary. Not a sharp wall, not a clean line, a zone of twilight. Astronomers call it the Terminator. On Earth, the Terminator moves constantly as the planet turns. On a locked world, it can remain fixed around the planet like a ring. This is where the idea becomes unsettling. If the day side is too hot and the night side is too cold, then the boundary between them may be the only region where liquid water could survive. But even that corridor would not be gentle. Winds from the hot side may crash through it. Cold air from the dark side may sink and pull across the ground. Clouds may stack along the boundary. Storms may form where the two hemispheres fight for balance. Survival there would depend on details: atmospheric pressure, cloud cover, surface water, ocean heat transport, the star's radiation, the planet's chemistry. This would not be a comfortable Earth. It would be a thin permission to exist, a habitable zone reduced to a border. We cannot stand on these worlds, but we are beginning to read them. The James Webb Space Telescope can measure tiny changes in infrared light as a planet moves around its star. That light carries heat information, and heat reveals climate. On some close-in planets, the day side appears far hotter than the night side. On others, the temperature pattern suggests that winds are moving energy around the globe. For TRAPPIST-1b, Webb measurements found a day-side temperature close to what models expect for a rocky planet with little or no substantial atmosphere carrying heat around it. For WASP-43b, Webb data allowed scientists to map temperature differences across the planet, with the day side far hotter than the night side, and winds shifting the hottest region away from the point directly under the star. For WASP-39b, Webb observations examined differences near the boundary between day and night, showing that even a narrow twilight region can have distinct temperature and cloud behavior. And other observatories have measured exoplanet winds moving at speeds that would make Earth's strongest storms look still. These are not copies of Earth. They are laboratories of imbalance. They show what happens when rotation, starlight, atmosphere, and gravity stop behaving the way our instincts expect. Each observation adds one more piece: a hot face, a cold face, a displaced hotspot, a chemical difference, a wind too fast to imagine. Together, they reveal the same truth. Some planets are not worlds with weather. They are weather systems stretched over an entire planet. The most disturbing possibility is not that these worlds are dead. It is that some may be almost alive. Not alive like Earth, not balanced, not forgiving, almost alive in one narrow region. Not a continent, not an ocean, only a belt, a fragile compromise between fire and ice. If the atmosphere thins, the night can start stealing the air. If the greenhouse effect grows, the day can push water toward loss. If the star flares, chemistry can shift. If circulation changes, the habitable band can move, shrink, or vanish. On Earth, climate danger unfolds across a rotating world. On a locked planet, the danger is built into the geography. You could travel toward sunrise and enter heat that never relaxes. You could travel toward night and enter cold that never ends. The map itself becomes a warning, and the only route through it is the line between two ways to die. A tidally locked world does not choose extremes. It is forced into them. Gravity fixes the face. Starlight punishes one side. Darkness drains the other. Atmosphere tries to carry the damage between them. Sometimes it may succeed. Sometimes it may fail. Sometimes it may create only a narrow strip where conditions briefly make sense. From a distance, the planet may look whole, a point of light around another star, but inside that point is a world split into incompatible realities. This is what makes these worlds so difficult to understand. Not every star survives alone. Some systems feed internally. One star grows stronger, while the other begins to disappear. A slow destruction measured in stolen matter. The universe does not need monsters. It has gravity, radiation, pressure, vacuum, and somewhere beyond what we can see, the next anomaly is already moving. This is space horrors, the universe that should not exist.